Welcome to the notes on polygons. All right, we're going to start by talking about the interior and exterior angles. Remember, interior means inside, exterior means outside. So let's take a look at the sum of the angles in a triangle. We've already been talking about some of this stuff already. But if we have a triangle, obviously has three sides. And what is the sum of the angles of a triangle? That's right, it's 180 degrees. All right, we learned that a square or any quadrilateral with four sides. All right, well, what does that add up to? 360 degrees. Now, a pentagon, five sides, you guys can see that. And if I said it added up to 540 degrees? All right, obviously, again, these are all in degrees. Do you guys notice a pattern? All right, well, 180, 360, 540. Well, hopefully you notice as the side goes up, all right, then you add 180. So what would you think the angles of a hexagon it would add up to? Well, a hexagon, that's six-sided. Well, we know that a pentagon's 540, so I would just say 540 plus 180. All right, so that answer would be 720 degrees. Yeah. All right, now, there is a formula to figure this out. I wouldn't expect you guys to just keep adding 180 each time. All right, the sum of the measures of an interior angles is as follows. All right, we're going to use this formula. We're going to take 180. All right, obviously you guys saw that pattern. And then we're going to times that by the number of sides minus 2. Okay, now remember, n equals the number of sides. So we're just going to put that into the formula to figure out what it would be, what our answer would be. All right, again, if you forget the formula, hey, we can always just keep adding 180 from the triangle if you need to. All right, so find the sum of the interior angles in an octagon. All right, well, an octagon is 8-sided, so I'm just going to use our formula right there. I'm going to take 180. I'm going to times it by now. N in this case is 8. All right. Again, 8 is N. So again, octagon, 8 sides. So I'm going to plug in an 8 here. All right. And then I'm going to finish out the rest of the thing. Minus 2. Well, 8 minus 2 is 6. So it's just 180 times 6. And when you do that, you're going to get 1080. So 180 degrees or 1080 degrees. All right, so now, how are we going to use that information to solve problems? Well, here's a problem that you guys will see. Find the value of x. Well, to find the value of x, we need to know what all those angles add up to. So let's count those sides real quick. I got 1, 2, 3, 4, 5, 6. All right, so what's the sum of those angles going to be? Let's use our formula. We're just going to take 180 times, in this case, it's 6 minus 2. Now, we already figured this out, but again, just kind of showing you guys, 6 minus 2 is 4. So 180 times 4, again, is 720. So we know that this is going to add up to 720 degrees. Now, once I know that, I just add up all the angles and solve. So I'll start here at 88. So I'm going to say 88 plus 142 plus 105 plus x plus 136 plus 136. That's all going to equal 720. And then at that point, it just becomes an algebra problem. You should get x plus 607 when you add all this stuff up. Obviously, you're going to subtract 607, so you're going to end up with x equals 113 degrees. So that's how you're going to use that to solve problems. All right, now we're going to talk about exterior angles. Okay, exterior angles, again, that means outside, all right, outside. So all you need to know for exterior angles, all right, no matter what the shape, all right, the sum of exterior angles, if you add them all up in any polygon, it's always going to equal 360 degrees. So every time I add up these exterior angles, and again, this is an example of an exterior angle. When you extend the side, all right, that angle formed right here, that is an exterior angle. Okay, now, we know they all add up to 360. What's the measure of one exterior angle of a regular polygon? Well, there's a key word here. Regular. Remember, that means all sides and angles congruent or the same. Well, to figure that out, you're just going to take, we know that they all have to add up to 360. So we're just going to take 360 divided by n. Again, n is the number of sides. All right, so that's going to be pretty simple. Now, relationship between interior and exterior angles, just keep this in mind, guys. They're always, I'm going to put a little star there, always supplementary. What's that mean, supplementary? Well, it means, again, they add up to 180. All right, again, add There's a little parenthesis to 180 degrees. So keep that in mind as you're working through these problems. And now here's two quick examples. All right, for the first one, find the measure of angle 1 in the regular hexagon. Well, angle 1, that's an exterior angle. We know all the angles at 360, so I just take 360, we just learned, divided by the number of sides, which is 6. So this angle right here is 60 degrees. All right, so angle 1 is 60 degrees. Now, if we want to find this angle right here, well, we know that they're a supplementary or they're a linear pair. So I'm just going to take 180 minus 60. So I know I'll do that right here, 180 minus 60, and that's going to equal 120 degrees right there. So be aware of that supplementary angles. Number 9, this last example, what do all the exterior angles of a polygon add up to? They add up to 360. So I'll start there, 2x plus 2x plus x plus 3x plus 4x. We know that they all add up to 360. Then it's an algebra problem. You combine those x's, you should get 12x equals 360 divided by 12. So x would equal 30. All right, and that's your final answer. So there's how we're going to use these properties of interior and exterior angles with polygons to solve problems in this section.